Assalamu alaikum. Today I will follow the lab 3.4 training a machine learning model in AWS Academy. Lab overview. In this lab you will continue exploring the biomechanical vertebral column dataset. You will first split the dataset into three separate datasets for training, validation and testing. You will then use this data to train a machine learning model using XGBoost algorithm. Objectives: after completing this lab, you will be able to split data into training, validation, and test sets, train a XGBoost model in Amazon SageMaker. Prerequisites: we have these. Duration is 30 minutes, and AWS console management. I have already started the lab and opened my AWS management console in here. So we will access to the Amazon SageMaker from here. We will go to the My Notebook instance. Yes, it is pending right now. Let me stop the video and continue after its status is ready. Okay, let's continue. I will open my notebook instance in Jupyter Lab. Okay, in here I will go to the machine learning 3.4 lab student notebook. Overview: in this lab, a continuation of the guided labs in module 3. In this lab, you will split the data into three separate datasets. Training set: this will be used in model training. Validation set: this will be used during training to validate the model. Test set: this will be held back and used to produce metrics after the model is trained. You will use this dataset in an upcoming lab. With the split data, you will train an XGBoost model by using Amazon SageMaker. Introduction to the business scenario: you work for a healthcare provider and want to improve detection of abnormalities in orthopedic patients. You are asked with solving this problem by using machine learning. You will have access to the data set that contains 6 biomechanical features and a target of normal or abnormal. You can use this dataset to train an ML model to predict if a patient will have an abnormality. About this dataset: this biomedical dataset was built by Dr. Henry Q. and Mota during a medical residence period in the group of applied research in orthopedics of the Centre Medico, etc. in France. The dataset has been organized in two different but related classification tasks. The first task consists in classifying patient as belonging to one of the three categories: normal, dysmenorrhea, and spondylolisthesis. For this second task, the category dysmenorrhea and spondylolisthesis were merged into a single category that is labeled as abnormal. Thus, the second task consists in classifying patients as belonging to one of the two categories, normal or abnormal. Attribute informations: Each patient is represented in the dataset by 6 biomechanical attributes that are derived from the shape and orientation of the pelvis and lumbar spine in this order: pelvic inducence, pelvic tilt, lumbar lordosis angle, sacral slope, pelvic radius, grade of symbiotesis. The following conversion is used for the class labels: dyscanria, syndiotesis, normal, abnormal. For more information about this dataset, see vertebral column dataset web page is in here. This is the original dataset. Dataset attributions, yes. Lab setup. Because this solution is split across several labs in the module, you must run the following cells so that you can load data. Importing data. By running the following cells, the data will be imported and ready for use. Note the following cells represent the K steps in the previous labs. Yes, as it says, we have already done this in the previous labs, so I will not go deep into this. We have already done the downloading of the dataset in the previous labs, so I will pause the video in here. Yes, we have downloaded our data, and in here we have the data. Let's go for the exploring the data. We have done the data exploration in the previous labs, so you will start with a quick reminder of the data in the dataset. To get the most out of step, carefully read the instructions and code before you run the cells. Take time to experiment. First, use shape to examine the number of rows and columns. Let's use the shape. We have 310 samples and we have 7 attributes. Well, actually, the last attribute, I guess. Let's see. Yeah, it is the class. So we have 6 attributes and 1 target attribute, we can say. Yes, we have 6 biomechanical features and the target column is named as class. Preparing the data. For this step, you must split the data into 3 datasets. An internet search will show many different ways to split datasets. Many code samples that you might find will split the dataset into the target and the features. Then they will split each of those 2 datasets into 3 subsets, which results in a total of 6 datasets to track. Moving the target column position. Yeah, in the target column, we shall move it into the first location. XGBoost requires the training data to be in a single file. The file must have the target value be the first column. Get the target column and move it to the first position. Yes, let's run it. Okay, let's see if it's in the first column. Yes, as shown in here. Splitting the data. You will start by splitting the dataset into 2 datasets. You will use the one dataset for training and you will split the other dataset again for use with validation and testing. You will use the train test split function from scikit-learn library, which is a free machine learning library for Python. It has many algorithms and useful functions such as the one you will use. For more information about the function, see training test split documentation. For more information about scikit-learn, see the scikit-learn guide. Let's see them. In here we have take a deeper look at the train test split method. And here we have the scikit official page. Yes, because you don't have a lot of data, you want to make sure that this split datasets contain a representative amount of each class. Thus you will use the stratigraphy switch. Finally, you will use a random number so that you can repeat the splits. So from scikit-learn model selection train test split, we split our data frame into training and test and validate. We have test size of 0.2, random state of 42, stratify df class. This stratify makes so that we have similar ratio about the classes we have. For example, the ratio of abnormal and normal should be same for the train and test data sets. So let's run it. Next, we will split the test and validate dataset into 2 equal parts. Yes, we have tests, train and test splits. Let's run it in the background. Okay, it was fast. We will use the test and validate data frame that we just got from the train test split, and we will once again split this into test and validate datasets. We have test sizes 0.5, random state 42, and certified test and validate class. Yes, so this test size makes it so that the half of the data set would be test and the other half would be validate. So in here as well we use the 0.2 like 20% of the data as validation, and the remaining 80% would be train data for training. Let's examine the 3 data sets. Let's see. Yes, as we can see, we have 248 records in the training and 41 for the test and validates. Now let's see the distributions, if they are like similar distributions. As you can see, we have the twice amount of the normal and abnormal ratio, like so. I guess 1 was the abnormal cases, or 0 for the normal. Yes, I really don't remember, so let's add a train dot head to see the attributes. Class is 1. And so yes, in here I have found it. 1 is for abnormal and 0 is for normal. So we can say abnormal to normal ratio is 2. We have the twice amount of abnormal cases compared to normal ones in the dataset. So this ratio should be kept for the training and testing datasets as well as the validation. So let's continue. Uploading the data to Amazon S3. XGBoost will load the data for training from Amazon Simple Storage Service, Amazon S3. Thus, you must write the data to a comma separated value CSV file and then upload the file to Amazon S3. Start by setting up some variables to the S3 bucket, then construct a function to upload the CSV file to Amazon S3. You can reuse this function. First, explore the function. Note the following line: data frame to CSV, CSV buffer, header false, we are ignoring headers, indexes false as well. So this line writes the pandas data frame, which was passed into the function, into the IO buffer that's named CSV buffer. You use a buffer because you don't need to write the file locally. To stop the column headers from being written out, use header is equal to false, as I told before. To stop the pandas index from being output, use index equals to false. To write the CSV buffer to Amazon S3 as an object, use put operation on the object, which is a property of the bucket. Let's see the code in here and execute it. We have a bucket ID in here. We add a prefix as lab3, and we have this file names. So we are getting the resource of S3 from the bottle3 session, and we are uploading this CSV by first converting the CSV buffer. Well, first we are getting the buffer from the IO, and we convert our data frame into CSV, and after that we put our output CSV file, and in here we are putting it, and we are using the prefix as lab3. We are putting it into the folder with the file name. File name is the, I guess, these are the file names. Yes. Use the function that you constructed to upload the 3 datasets. Yeah, now we will upload this CSV. Let's see. Yes, we have successfully uploaded the files. Step 3, training the model. Now that the data in S3, you can train a model. The first step is to get the XGBoost container URI. Okay, we are importing bottle3 from SageMaker image URIs. We are importing retrieve. We are using XGBoost algorithm. We are using actually US East 1. I can provide that as well as region. So we are using the version 1.0 .1, I guess. Let's see if it works. Yeah, I guess we should keep the session name as this. And next, you must set up some hyperparameters for the model, because this is the first time you are training the model. You can use some values to get started. Let's use these hyperparameters. Use the estimator function to set up the model. Here are a few parameters of interest. The instance count, this defines how many instances will be used for training. You will use one instance. Yes, we can parallelly use the instance to train our model. So the instance type, this defines the instance type for training. In this case, it's ML and for X large. So let's run this. And output location would be the bucket name, the bucket ID, I guess. So the prefix was the lab3, and we have the XGBoost model by using the estimator container SageMaker get execution role. We are getting some IAM role in here, I guess. Instance count is 1, and we are using the MLM4XArch instance. Output path was this. Then the hyperparameters and SageMaker session, SageMaker.session. Okay. Let's see if we have processing jobs in here. Not yet. The estimator needs channels to feed the oh yeah, we haven't feed the data yet. We have just constructed the model, but we haven't started the training session. So the estimator needs channels to feed data into the model for training. The train channel and validate channel will be used. Okay, this is the training channel, this is the validate channel, and let's see. Okay, running fit will train the model. Note this process can take up to 5 minutes. Let's see. Okay, after this training complete, you are ready to test and evaluate the model. However, you will do testing and validation in later labs. Okay, let's see if it's now training jobs, I guess. Yeah, in here it's in process. So let me stop the video and continue after the process is completed. So yes, the training is now completed. Let's see the status of the training. Let's see details. Okay. So in here we have like 3 minutes, actually 2 minutes for training, and we have some other details in here, I guess. So we can see the hyperparameters in here. So yes, we have the output model in here, I guess. S3 model artifact. Let's see that. Well, I guess guess we don't have permission for that. So, and this is the end of the lab. So thank you for listening me.